Something just passed through your skull. You didn't feel it. You couldn't. It was smaller than an atom and moving at nearly the speed of light. It came from a supernova that exploded 10 million years ago. A star died, and one of the particles from its death just intersected with your brain. This happens constantly, about 10,000 times per second. Most pass through harmlessly, but some don't. And when they don't, they change things. In 2003, a local election in Schaerbeek, Belgium, had a problem. One candidate received more votes than voters. Specifically, 4,096 more votes than the machine should have recorded. That number matters. 4,096 is 2 to the 12th power. In binary, it's a single digit, a 1 where there should have been a 0. Investigators traced the error to a bit flip in the voting machine's memory. The cause: a cosmic ray struck the machine at exactly the right angle to flip one bit of data. One particle, one bit, one altered election. This is a documented phenomenon. A Qantas flight nosedived 690 feet in 2008 from a bit flip in the flight computer. NASA investigated Toyota's unintended acceleration reports and seriously considered cosmic ray interference. We radiation-harden spacecraft computers. Satellites use error-correcting memory specifically because cosmic rays flip bits. We protect our machines. We don't protect our brains. Your neurons communicate through tiny electrical signals. The threshold for a neuron to fire is about 70 millivolts. A single cosmic ray can carry billions of electron volts. Billions. The most energetic cosmic ray ever detected carried the kinetic energy of a baseball thrown at 60 miles per hour, all concentrated in a single proton. When particles like this pass through biological tissue, they leave a trail of ionization. They knock electrons off atoms. They break chemical bonds. Most of this happens in your body's tissues and doesn't matter. Cells die and are replaced. But your brain is different. Your neurons don't regenerate the same way. The patterns of connections, the timing of signals, the electrochemical states that encode your thoughts, these are fragile. A cosmic ray passing through your prefrontal cortex at the moment of a decision could alter the state that tips the balance between one choice and another. You would never know. The thought you were about to have would simply be different. And you would experience that different thought as your own. Roughly 200 particles pass through your brain every second. In a lifetime, approximately 500 billion cosmic ray particles will have passed through your brain. Most interact with nothing. They pass through the empty space between atoms, but some don't. The exact rate of meaningful interactions is unknown. We can't put a number on how many of your thoughts have been altered, but the number isn't 0. Here's what makes this disturbing. If a cosmic ray altered one of your decisions, you would have no way of knowing. The altered thought would feel exactly like your own, because it would be your thought, just not the thought you were going to have. There's no original version to compare it to. You might have married someone different, taken a different job, said something you wouldn't have said, all because a particle from a stellar explosion happened to pass through your prefrontal cortex at exactly the wrong moment. Or exactly the right moment. We have no way of knowing. Every decision you've ever made happened inside a brain being bombarded by particles from dying stars. Every thought you're having right now is occurring in a substrate that cosmic rays are passing through as you listen to this. We like to believe our minds are sovereign territory, private, self-determined. But the borders are open. They've always been open. The next thought you have might be entirely your own, or it might be the result of a supernova that exploded when dinosaurs walked the earth. You'll never know which thoughts are yours, because the thought that would question it just got rewritten too.